The most powerful telescope humanity has ever built just showed us something we were never supposed to see. And honestly, nobody knows what to make of it. This isn't just another space discovery that gets filed away in some academic journal. This is the kind of thing that could reshape everything we thought we knew about the origins of our universe, about time, about space, about reality itself. So the question hanging in the air right now is this: are our fundamental truths about the cosmos starting to crumble under the weight of new evidence? The James Webb Space Telescope launched on December 25, 2021. As of this recording, it's been observing the universe for almost 4 years. And in that relatively short time, it hasn't just revolutionized astronomy. It's shaken the very foundations of physics. Webb was designed with one crystal-clear ambition: to see the past of the universe with a clarity no instrument before it could achieve. It was built to reach regions so distant and therefore so ancient that its lenses capture light from the very first stars and galaxies that flickered into existence after the Big Bang. But it doesn't stop there. James Webb also dives deep into thick clouds of cosmic dust, the kind that hides stellar nurseries and newborn planetary systems, revealing processes the human eye could never witness on its own. To pull all of this off, Webb needed a superpower. And that superpower is a giant mirror. Its primary mirror is much larger than Hubble's, more than double the diameter, with a light-collecting area almost 6 times greater. That means it can detect incredibly faint signals, like whispers traveling from the beginning of time itself. But size isn't everything. Webb is also a specialist in the infrared spectrum. Its instruments operate across a broader range and with a sensitivity that leaves Hubble in the dust. It's like swapping out a regular flashlight for a cutting-edge thermal camera. And here's another thing: Webb doesn't just orbit Earth like Hubble does. It's stationed far away at a gravitational sweet spot known as Lagrange point 2, or L2. Out there, it stays cold, stable, and has a crystal-clear view without interference from our planet. That distance gives it a level of precision and observational efficiency that Hubble, despite being a legend in its own right, simply can't match. So why does infrared make Webb so much more powerful than Hubble? Let me break it down. Webb's main camera can see exactly what the most distant parts of the universe are emitting: infrared light. There are 3 main reasons this matters. First, there's something called redshift. Because the universe is expanding, light from the earliest stars and galaxies gets stretched out, literally pulled toward longer wavelengths. What used to be visible light billions of years ago now only shows up in the infrared. Telescopes that aren't designed for this simply can't detect that ancient light. Second, cosmic dust isn't a problem for James Webb. Regular visible light hits clouds of dust and stops dead. Infrared, on the other hand, cuts right through. The result? Webb can see inside stellar nurseries and hidden regions that other telescopes only see as dark, blurry patches. And third, being far from Earth makes a huge difference. Ground-based observatories suffer from 2 major issues. 1. Earth's atmosphere absorbs most of the infrared coming from space. 2. The atmosphere itself emits infrared. It's like trying to take a photo in the dark while someone points a spotlight right at your camera. That's exactly why Webb can see its targets with such stunning clarity. It can record signals so faint they'd be completely swallowed up by Earth's atmosphere. And the best part? It's only just getting started. The very first image Webb captured and sent back stunned all 3 agencies involved in the project: NASA from the United States, ESA from Europe, and CSA from Canada. Dubbed Webb's first deep field, the image shows SMACS 0723, a galaxy cluster located at least 4.6 billion light-years from Earth. That means this image shows what the universe looked like around the time Earth was just beginning to form. Kind of mind-blowing when you think about it, right? Released to the public on July 11, 2022, the composite image was taken by Webb's near-infrared camera, or NRCam, and covers a tiny patch of sky visible from the southern hemisphere. Thousands of galaxies are visible in the frame. It was, at the time, the highest resolution image of the early universe ever seen. Another image that amazed the world was the Carina Nebula, also known as Eta Carinae. It had already been photographed by the Hubble Space Telescope, and when you compare Hubble's image with the one from Webb's NRCam, The difference is staggering, especially in terms of depth of field and sharpness. The Carina Nebula is located about 7,500 light-years from Earth in the constellation Carina. It's a gigantic stellar nursery, a place where stars are born, die, and ironically, compete for space. Ironic because, well, they're in a cosmic environment where space isn't exactly in short supply. But we're talking about objects that are massive, far larger than our sun, incredibly dense, with gravitational forces that are off the charts. And they're the result of catastrophe. Let me explain. The nebula has a main star called Eta Carinae. It's a binary star system, supermassive, that exploded without exploding. Literally. In the mid-19th century, the star went through what's called the Great Eruption, spewing an absurd amount of material and shining almost as bright as a supernova, except it survived. The result of this near-death experience is the Homunculus Nebula, the name given to two enormous bubbles of gas and dust that are still expanding today. Eta Carinae is a landscape of chaos and creation. Supersonic jets slice through dense clouds. Stellar winds carve out caverns and pillars. Shock regions glow in the infrared like embers in a fire. In this case, a cosmic fire you definitely wouldn't want to be anywhere near. When James Webb pointed its infrared gaze at Eta Carinae, it was like turning on stage lights over a scene that had always been covered in fog. Hubble had already explored the region in visible detail, but Webb sees what's hidden. In dust-heavy regions where Hubble only saw darkness, Webb revealed internal cavities, extremely thin filaments of hot gas, shock waves layered like the rings of a cosmic onion, and dense pockets on the verge of forming new stars. It's like experiencing a storm from the inside. With its spectroscopic instruments, Webb identified signatures of ionized hydrogen, carbon, silicates, sulfur-rich compounds, and even complex molecules whose existence in such a brutal environment isn't yet fully understood. Either way, the data Webb gathered is helping astronomers better understand the composition and evolution of the clouds expelled during the Great Eruption. In this other comparison image, we're looking at the same star cluster, NGC 346. The first image was taken by Hubble, the second by James Webb. The difference is incredible, right? As for it being a stellar nursery, Webb found signs of star formation in Eta Carinae through tiny infrared light sources. In other words, stars are literally being born inside cocoons of dust, something impossible to see in the visible spectrum. But why does this matter? Well, these observations have expanded our understanding of how supermassive stars lose mass over their lifetimes, how large stellar eruptions shape nebulae, how turbulent regions can paradoxically give birth to new stars, and how extreme binary systems interact, influencing explosions and stellar events. The Carina Nebula is a kind of natural laboratory for studying the origins of stars and maybe entire solar systems. James Webb, with its ability to pierce through curtains of dust, has been bringing us images and information that until recently were just blurry smudges. Now we're seeing a much clearer, more detailed, and more dramatic mosaic. And the most fascinating part? Even after revealing so much, Webb has only reinforced the feeling that Eta Carinae still holds secrets. It's as if the star is getting ready to put on, no pun intended, the greatest supernova show of the next few thousand years. Too bad we won't be around to see it. Another nebula that left astronomers enchanted, in the best sense of the word, was the Red Spider Nebula, or NGC 6537. The first sharp image of it was captured in 2001 by the Hubble Space Telescope. That image already showed scientists a lot, but what would come years later with James Webb would be fantastic. The image taken by Webb, as you're seeing now on your screen, is infinitely sharper and more detailed than the previous one. The Red Spider Nebula has always sparked curiosity because of its iconic shape. But it was only when James Webb pointed its infrared eyes at it that the full picture really opened up. For the first time, the telescope's wide field of view revealed the complete extent of its enormous tentacles, or better yet, legs. These are elongated structures, inflated by millennia of expanding gas, each stretching about 3 light-years. The Red Spider is a planetary nebula. Despite the name, it has nothing to do with planets. It's the product of the final gasps of a star similar to our Sun. When the nuclear fuel runs out, The star expands into a red giant and eventually ejects its outer layers. The hot core that remains radiates ultraviolet light, making the expelled material glow like a short-lived luminous sculpture. A spectacle that lasts only a few tens of thousands of years. Webb brought a fresh perspective to the heart of this process. While Hubble saw only a faint bluish star at the center, Webb's infrared vision revealed an intense red point wrapped in a cloud of hot dust. This dust probably forms a disk around the star, invisible in the optical spectrum but brilliant in infrared. And there's another intriguing detail. The hourglass shape of the nebula suggests this star isn't alone. The symmetry, the narrow waist, and the expansion of the outer regions are classic signs of a binary system, where a still-hidden companion star helps shape the flow of gas. It's the same pattern observed in other complex planetary nebulae, like the famous Butterfly Nebula. The spider's legs are perhaps the most impressive feature. The vast bluish lobes are made of molecular hydrogen and now appear with total clarity thanks to Webb's field of view. They reveal themselves as giant bubbles, trapped and slowly inflated over centuries of stellar winds. Meanwhile, the center of the nebula continues to boil with activity. There's a sinuous S-shaped feature that, according to scientists, consists of jets of ionized iron launched at high speed from the stellar core. These jets slam into previously ejected material, carving out wavy patterns that give the red spider its menacing yet stunningly beautiful appearance. These observations are part of a program led by scientist J. Kastner, dedicated to understanding how outflows and jets shape bipolar planetary nebulae. Ultimately, it's an investigation into how stars die and, indirectly, a glimpse into the distant future of our own sun, when it too will create its last luminous work of art in space. We could stretch this video out a lot longer. However, the time has come to talk about James Webb's new discovery, the one that's turning astronomers' heads. What did the space telescope see in the far reaches of the universe that could shake the foundations of our knowledge? Would you care to guess? Well, I'm excited to tell you. In a remote corner filled with ancient light, James Webb captured what at first seemed to be just a simple yellow smudge. But when astronomers looked more closely, their assumptions fell apart. That tiny bright dot wasn't just another galaxy. It was the most distant galaxy ever seen, formed just 290 million years after the Big Bang. But here's the controversial part. It's too massive, too bright, and too evolved to have formed so soon after the Big Bang. According to conventional theories, 290 million years is far too short a time to accumulate enough material to form a galaxy like this newly discovered one. 290 million years after the initial boom, the universe was still in its infancy. Planets didn't even exist yet, and galaxies were only just beginning to sprout. And yet, there it is. And it's not alone. James Webb has already found dozens of others exactly like it. Each one is a cosmic paradox, breaking every rule we thought we understood about the early universe. When astronomers decided to take a closer look at those points of light detected by James Webb, they expected to find just more young, turbulent galaxies. But what appeared before them was something that doesn't fit any known logic. Among the oldest objects ever observed, structures emerged that aren't just incredibly massive, they're absurdly anomalous. Normal galaxies convert only a fraction of their gas into stars, something around 10%. But Webb identified at least 3 objects that seem to have gone to the absolute limit, transforming all of their matter into stars. No leftover gas, no dust, just clusters of pure light, as if they'd been sculpted from solid brightness. According to available models, this simply shouldn't exist. Given all this, the question has shifted. Maybe these things aren't galaxies, at least not in the traditional sense. What if we're looking at something completely outside our physical reality? A structure from some earlier stage of the cosmos? An echo from another universe? Or even a type of matter that shouldn't be here at all? James Webb may have revealed not just a primordial universe, but something that completely escapes the rules we thought were unchangeable. Well, now we wait for the results of the studies and find out what else extraordinary James Webb will send back to Earth. Until then, sit with these images, with these mind-bending thoughts, and thanks so much for your company. See you in the next video.